Hello, this is Mr. Stein, and in this video we are going to go through the example problems about interpreting and sketching graphs. After this lesson, you should be able to draw a detailed graph from a situation and vice versa, determine the independent and dependent variables and compare them to the domain and range, use the steepness of a graph to indicate different rates of change. All right. Example problem number 1. This graph represents a day trip from Athabasca to Kikino in Alberta, a distance of about 140 kilometers. Describe the journey for each segment of the graph. All right, if you take a look at the graph, there is 1, 2, 3, 4, 5 segments that we are going to describe. The first segment is O to A. And we're going to talk about how long it took and the distance traveled. Then we can determine the rate of travel. All right, from O to A, it took 2 hours. From here to here, it took 2 hours, and they traveled 140 kilometers. And they traveled away from home. So they had a rate of 70 kilometers per hour. That's a positive 70 kilometers because they're going away from home. That's O to A. Let's take A to B. A to B took 1 hour. They traveled 0 kilometers for a rate of 0 kilometers per hour. They were stopped at Kikino. Then from B to C, they start coming home. And we're going to have to kind of interpolate how far they drive, B to C. It takes 3/4 of an hour. 3/4 of an hour. Let me just write that properly. 3/4 of an hour. So it's from here to here. And they drove from 140 down to 90, so 50 kilometers. Now, we should be able to figure that out as a rate. We do 50 divided by 0.75 gives us a rate of 66.7 kilometers per hour. Now, they're going back home, so this is going to be a negative rate. We could also consider the distance to be a negative distance because they went from far away to closer. C to D. C to D is another 3/4 of an hour. 3/4 of an hour. They traveled 0 kilometers, that's how far up and down it went, for a rate of 0 kilometers per hour. Our last one. From D to E. From D to E took 1 hour. And they went from 90 kilometers away to 0 kilometers away. So they traveled negative 90 kilometers for a rate of negative 90 kilometers per hour. Our rates are indicated by the steepness of the graph. You can see that B to C is not quite as steep as D to E. It's because B to C does not have as high a rate, as steeper rate as D to E does. The velocity is not as big. All right, so you should be able to relate the steepness of a graph to the rate of something from the graph. The domain is our time, and our range is our distance. All right, example number 2. Each point on this graph represents a person. Explain your answer to each question below. Letter A. Which is the independent variable? Which is the dependent variable? Independent. Independent variable is our age. Sorry, I wanted to highlight that. Our age. And I'm going to need to go back to green. And our dependent variable is our height. Now this should kind of make sense if I read it this way. Your height depends on your age. So how tall you are depends on how old you are. Right? When you're young, when you're 1, you're shorter than when you're 2. When you're 2, you're shorter than when you're 3. Your height is dependent on your age. So height is the dependent variable. So I'm just going to say that. Height depends on age. It doesn't really make sense to say the age of a person depends on their height, i.e., this person is shorter, therefore his age is smaller. All right, letter B. Which person is the oldest? Well, we look on our domain, we find G. Letter G is the oldest. And if we follow letter G down, letter G is 18 years old. Question C. Which person is the youngest? We highlight letter A. We follow letter A down, and letter A is 0 years old. Letter D. Which two people have the same height? These two guys both have the same height. If we look across, they're both 100 centimeters tall. So B and C are both 100 centimeters tall. Letter E. Which two people have the same age? E and D have the same age, and they are both 10. E and D are both 10 years old. Which person, B or C, is taller for their age? Well, they're the same height, so we look at which one's younger. So B is taller for his age, or her age. Now the question is this graph a function? I'm going to erase a bunch of stuff on here. Is this graph a function? Does each domain value only have one range value? Well, let's look at a few of the domain values. Our domain value of 0 only has one value of A. Our domain value of 2 only has one value of 100. Our domain value of 3 only has one value of 100. Our domain value of 10 has two values, 125 and 150. Domain value of 14 has only one value. Our domain value of 18 also has only one value. But because of this right here, this is not a function. It is not a function because the domain value of 10 years old has two range values. For a relation to be a function, each domain value has to have exactly one range value. All right, so we're going to take a look at example 3 in just one moment. And this application's been doing this quite a bit, but we'll take a look at example 3. At the beginning of the race, Alicia took 2 seconds to reach a maximum speed of 8 meters per second. Then she ran at 8 meters per second for 12 seconds, then slowed down to a stop in 2 seconds. Sketch a graph of speed as a function of time. Whenever it's worded this way, speed as a function of time, that means that speed is our dependent variable. Time is our independent variable. Label each section for your graph and explain what it means. All right, so time is going to be our domain value. So we put time down here along the horizontal axis. We have to have 0 seconds, 1, 2, 3, 4, 5 seconds, 6, 7, 8, 9, 10 seconds, 11, 12, 13, 14, 15 seconds. There's our time in seconds. And our speed is measured in meters per second. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's take a look. The first section. So Alicia took 2 seconds to reach a maximum speed of 8 meters per second at the beginning of the race. So Alicia started at 0, then took 2 seconds to get up to 8 meters per second right here. That's her first section right there. She accelerated. So she accelerated in the first from 0 meters per second up to 8 meters per second. Then she ran at 8 meters per second for 12 seconds. So we'll take a look at the second section. She ran at 8 meters per second for 12 seconds. That's the second section. So from here, for 12 seconds, puts her up to 14 seconds right here. So this is steady pace. No acceleration. This section here is speed up. Accelerate. And now the last one, the last section. Slowed down to a stop in 2 seconds. So she slowed down to a stop in 2 seconds. So it took her 2 seconds to slow down to a stop right here. So this is the slow down. Now, both of these, the speed up acceleration phase and the slow down deceleration phase, both have rates of acceleration. In the first section where she's speeding up, she's accelerating plus 4 meters per second in every 1 second. Right, every 1 second, so start here, every 1 second she speeds up 4 meters per second. In the slow down phase, she's slowing down -4 meters per second every 1 second. This is her acceleration rate. All right. So